Guys, in this video we will discuss about the alternating series. So what is alternating series? That is a series containing alternately positive terms and negative terms. Negative terms is referred to as an alternating series. That means suppose we consider this series, that is un minus u2 plus u3 minus u4 plus dot so on, where un is greater than 0 for all n belongs to n, that means a natural number. Then we can write it in the compact form, that is summation n is equal to 1 to infinity minus 1 whole to the power n minus 1 un. So now the question is that how can we check the convergency of this alternating series? So for checking the convergency of the alternating series, we will take the help of Leibniz Theorem. So what is the statement of Leibniz Theorem? That we can say that an alternating series is said to be convergent. Suppose first we construct a sequence un for all n belongs to n, that is a natural number. If these three conditions are satisfied, that means the un is greater or equal to 0. That means all the terms of the alternating series are non-negative. Un plus 1 less equal to un, that means the sequence un is monotone decreasing. Un is monotone decreasing. And number 3, that is limit n tends to infinity, un is equal to 0. And if an alternating series altogether holds these three conditions, then we can say that the alternating series is convergent. So now I will explain here two problems, that which is convergent and which is non-convergent, that means the divergent. So first we take this problem, that is the series, alternating series, that is 2 minus 3 by 2 plus 4 by 3 minus 5 by 4 plus dot so on. So by observing this, that here the terms are, the positive terms and negative terms are alternately, so we can say this is an alternating series. And see here, we can construct the sequence un from here, that is n plus 1 by n. And see here, if we put n is equal to 1, we get the first term 2. If we put n is equal to 2, we get the second term 3 by 2. And if we put the 3, n is equal to, then we get the 4 by 3 and so on. So this is the sequence un is equal to n plus 1 by n. And what is now un plus 1? That is, now we replace n by n plus 1, and so we get n plus 2 divided by n plus 1. So now let us check that the three conditions are satisfied or not. So here that un is equal to n plus 1 by n. So we can say from here that for all n belongs to n, un is greater than 0. So the number 1 condition is satisfied. Now we have to check the second one, that is the un plus 1 less equal to un, that is un is monotone decreasing or not. So now we have to find the difference of un plus 1 and un. So what we get here, un plus 1 minus un, we get that n plus 2 divided by n plus 1 minus n plus 1 by n, and if we simplify, we will get minus 1 by n into n plus 1, which is less than 0. So the second condition is also satisfied, that is the sequence un is monotone decreasing. So now let us check the third condition, that is limit n tends to infinity, un is equal to 0 or not. So now here we check that the limit n tends to infinity, un, and here un is equal to n plus 1 by n, and if we simplify, we get limit n tends to infinity 1 plus 1 by n, and if we simplify, as n tends to infinity 1 by n is 0, so is equal to 1, which is not equal to 0. So the third condition is not hold. So now we can say that the given alternating series is not convergent. So I hope you understand the first problem. So now I will take another problem, and let us check that this series also convergent or divergent. So see here we take the problem, that is 1 by 2 cube minus 1 by 3 cube 1 plus 2 plus 1 by 4 cube 1 plus 2 plus 3 minus 1 by 5 cube 1 plus 2 plus 3 plus 4. So from here we have to find the terms un, that is the nth term of the sequence. The nth term of the sequence, we can say here that un is equal to 1 by n plus 1 whole cube into 1 plus 2 plus 3 plus dot dot plus n. I hope you can see it. And see here now, if you put n is equal to 1, you get the first term. If you get the 2, then you will get the second term, and so on. So now what can we now write? That 1 by n plus 1 whole cube, and this is the sum of nth terms. So here we get n into n plus 1 by 2. And now from here, if we simplify, we get half of n by n plus 1 whole square. So now, and we can say that from here, un plus 1, that is n is replaced by n plus 1, that is n plus 1 by 2 into n plus 2 whole square. So what is un here? That is half of n by n plus 1 whole square. So from here we can say that all the terms are greater than 0. So the first condition of the Leibniz theorem, that is un is greater than 0, is satisfied. So now we will check that the sequence un is monotone decreasing or not. So here we will find un plus 1 minus un. So the difference of un plus minus un, if we simplify it, that is half common, n plus 1 divided by n plus 2 whole square minus n by n plus 1 whole square. And if we now simplify, we will get minus half of n square plus n minus 1 divided by n plus 1 whole square into n plus 2 whole square, which is less than 0. So now we can say that the second condition of the Leibniz theorem, that is the sequence un is monotone decreasing, it is also satisfies. Un is monotone decreasing, this is also satisfies. So now I will check the third condition, that is limit n tends to infinity, un is equal to 0 or not. So now let's see, that is limit n tends to infinity, limit n tends to infinity, un is equal to, now we can write here that limit n tends to infinity half of n divided by n plus 1 whole square. And from here we can write it like as limit n tends to infinity half of n divided by n square 1 plus n whole square. And from here, as n tends to infinity, so we get here limit n tends to infinity 1 by 2n, and which is also tends to 0, or from here we can write this is equal to 0 as n tends to infinity. So our third condition of the Leibniz theorem is satisfied, and now we can say that the given alternating series is convergent. Given alternating series is convergent. So I hope you understand that how can we check the convergence of the alternating series. So thank you.